Good day, ladies and gentlemen. In experiment 3, we were using hydrogen sulfide and sulfur dioxide to reduce our transition metals. In this experiment, we will be using hydrogen peroxide, sodium bismuthate, and sodium permanganate to oxidize our transition metals. Oxidation of our transition metals means their oxidation states will increase. So hydrogen peroxide is classified as an oxidizing agent. Now, another reaction can happen with hydrogen peroxide. It can undergo thermal decomposition. Thermal just means hot. So if you put hydrogen peroxide in the sun, it will start to decompose and you will observe some bubbles forming. Now, here's the equation for hydrogen peroxide decomposition, and you can see when it decomposes it forms water and oxygen. So oxygen is those bubbles that you are observing. There are 3 transition metals on the periodic table which is very close to each other: iron, cobalt and nickel, and they can all catalyze CO hydrogenation, another word for Fischer-Tropsch reaction and methanation. But they do react very differently when it comes to hydrogen peroxide, and it also is about the different oxidation states that they can have. For example, iron 2 plus would like to be oxidized to iron 3 plus because iron 3 plus has got 5 electrons in its d orbitals, resulting in the d orbitals being half full, and a half full d orbital subshell is very stable. So therefore iron 2 plus would really like to be oxidized to iron 3 plus. However, it's not the case for nickel and not the case for cobalt. So when you have iron 2 plus and you add it with hydrogen peroxide, which is an oxidizing agent, it would readily oxidize to iron 3 plus. So your oxidation state of the iron has increased from +2 to +3. So your iron has oxidized, so the oxidation has increased. So let's look at the oxidation state of oxygen. Now this oxygen is part of hydrogen peroxide. So it's a peroxide, which means this oxygen has got a oxidation state of -1. And here we have water. Water is obviously not a peroxide, and therefore this oxygen will have an oxidation state of -2. So our oxidation state has changed from -1 to -2. So the oxidation state has decreased. So the oxygen has undergone reduction. Your iron has undergone oxidation, your oxygen has undergone reduction. So we have a redox pair. So this is a redox reaction. Now cobalt 2 plus and nickel 2 plus is not readily oxidized by hydrogen peroxide. Cobalt 2 plus and nickel 2 plus are already very stable oxidation states. So when cobalt 2 plus and nickel 2 plus is mixed with hydrogen peroxide, it is not readily oxidized. And the only thing that one would observe is the decomposition of the hydrogen peroxide to water and oxygen.